Please pause the video and read the problem. Okay, let me explain this example. First, let me define the events. How many major events are in this example? There are 4 major events. What are those? I define as A. Policyholder dies next year. B1. Policyholder has standard policy. B2. Preferred policy. And B3. Ultra preferred policy. Now let me write down the given information, given probabilities. First one, 60% are standard. Right, what is the standard? B1. Therefore, probability of B1 is 0.6. But what is the rest of the sentence? 60% are standard with the probability of 0.05 of dying next year. Now they are talking about the policyholders dying next year. The probability of A, that is 0.05. But they are talking about only one group. What is the group? That is standard policy group. Therefore, we know this is coming from the standard policy holder group. Therefore, it becomes a conditional probability. So, probability of A given B1 is 0.05. Next one, 30% are preferred. You know that means probability of B2 equal 0.3. Similarly, the rest of the sentence says with the probability of 0.03 of dying next year. Right, that means again they talk about probability of A dying next year, but they talk about now only preferred policyholders. Right, therefore we know it become a conditional probability. So probability of A given B2 equal 0.03. Similarly, you can write these probabilities. So probability of B3 equal 0.1 and probability of A given B3 equal 0.01. Alright, now let me explain this using the Venn diagram. First, understand this story. They are talking about 3 policyholders, right? It means what is our sample space? People, right? And these people divide into 3 groups only. Therefore, I can draw Venn diagram like this. Y, B1, B2, B3. So whole people only 3 groups, right? B1, B2, B3. And also B1, B2, B3 are disjoint, right? So go to the now event A. What is the event A? Policyholder dies next year. Okay, we can find policyholders who die next year from each 3 groups, right? From B1 and from B2 and also from B3. Therefore, we need to draw the A event like this. So it is represent the each groups, right? Okay, now you see there are 3 groups of A. What are these 3 groups? A intersection B1, A intersection B2, A intersection B3, right? We can write A intersection B1 union A intersection B2 union A intersection B3, and keep in mind these 3 events are disjoint. Okay, so how do we find the probability of A? You know, we can get the probability of the expression at the right side. Now, as I mentioned before, we know these 3 events are mutually exclusive events. That means disjoint event. Therefore, we can write this. Probability of A equal summation of each events only. Probability of the each events, right? Now you know the conditional formula, this formula. So you can apply this formula for each cases. So each case. So now you can write the this formula. What is this formula? This is a law of total probability. This is the law of total probability. Now let me go to the part A. What is the probability that a policyholder of this certain age will die next year? They are talking about policyholder die next year. Therefore, we know A is the policyholder dies next year, so we need to find the probability of A. How do we find the probability of A? I just explained the law of total probability. So by this law, we can write this according to our example, our information. Now we know each probability, so we can just plug the numbers and simplify. So probability of A is 0.04. Right, go to the part B. A policyholder of this certain age dies next year. What is the probability that the deceased was a preferred policyholder? Right, asking what is the probability that the deceased was a preferred policyholder. We know B2 is the event that preferred policyholder, right? But they are asking probability of B2, but there is a condition. What is the condition? It says a policyholder of this certain age dies next year. So they are talking about this group. Policyholder dies next year, right? So therefore, it becomes a conditional probability. That means probability of B2 given A. So how do we do that? You know Bayes theorem or Bayes rule. So by the Bayes rule, you can write this. Now you know each probability and plug the numbers and get the answer. That is 0.225. Right. Go to the part 3. A policyholder of this certain age does not die next year. Does not die next year this time. Okay, now they talk about does not die next year group, right? Actually, there are two groups, dies next year and does not. Okay. From that group, does not die, what is the probability that this policyholder is ultra prepared? You know ultra prepared, that is the B3, but we know A is the policyholder dies next year. Then how do we write the event that policyholder does not dies next year using A? Yes, that should be A complement. Therefore, there should be probability of B3 given A complement. Okay. Let me start this from the conditional probability, right? This is a conditional probability. So I start from this. You know probability of B3 given A complement equal probability of B3 intersection A complement divided by probability of A complement. Then what is the next? And you can write down this one and plug to the top of the right side. Okay, you see the probability of B3 and A complement, right? So you can plug it. So then you can write this, and I write down probability of A complement. I write down 1 minus probability of A. Why I write that way? Because we don't know probability of A complement, but we know the probability of A. So because we found that probability from the part A. So we know those probabilities. So now you can write down this way. Okay, here probability of A complement given B3, it is unknown. But we know probability of A given B3. Therefore, we can write down 1 minus probability of A given B3. Okay, and time probability of B3 and divided by 1 minus PA. Now we know all the probabilities and plug the numbers and you can get the answer. That is 0.103.